Welcome back everyone. Today we learn about solubility of salts. We will be discussing the salts of chloride, sulfate, carbonate, nitrate, iodide and hydroxide. For chlorides, all are soluble except lead and silver. For sulfate, all are soluble except lead, barium, while calcium is sparingly soluble. For carbonates, all are insoluble except for group 1 and ammonium, while for ammonia all are soluble. For iodide, all iodide salts are soluble except lead and silver. And lastly, for hydroxide, all are insoluble except for group 1, ammonium and barium, while calcium hydroxide is sparingly soluble. Qualitative analysis. The areas we will be focusing on are color, cation test, anion test, and test for metal, alkali, acid, and gas. Color. With respect to metals, all metals have a silvery appearance. And when it comes to white solids, most salts or crystals are white in color, with some of the examples listed below. And here are some examples of a colorless solution, with soluble salts forming colorless solutions. Some examples of colorless gases include oxygen, hydrogen, carbon dioxide, and carbon monoxide. And here are some examples of green solids. There are also blue salts or solutions which include copper nitrate, copper sulfate, and copper hydroxide. The examples of brown solids are as follows. And here are the examples of brown solutions. However, in the case of iodine, it is only a brown solution when it is dissolved in aqueous potassium iodide solution, with equation stated below. These are the examples of yellow solutions as well, with aqueous bromine being yellow only at low concentration. While for aqueous bromine of a low concentration will be orange as well. For brown gas, the examples include vaporized bromine gas and nitrogen dioxide. And the examples of black solids are copper oxide, carbon, and iodine crystals. The iodine solids are that of a dark crystal, while iodine vapor is violet and it will dissolve in water to form a yellow color, while dissolving in potassium iodide to form a brown solution. Some may ask, why is iodine rather insoluble in water? It is because iodine is a covalent compound and hence instead is only mildly soluble in polar solvent. Here are some examples of a yellow solid which includes sulfur and lead oxide, while yellowish gas includes fluorine and chlorine. However, in the context of an exam, fluorine and chlorine will be pale yellow while bromine is intense yellow and iodine is yellow. An example of a red solid is copper oxide. Test for cations. The first test for cations is to add sodium hydroxide and check for a precipitate and afterwards state the color of said precipitate. If a precipitate is formed, add sodium hydroxide in excess to check whether the precipitate dissolves or remains insoluble, and if no precipitate is formed, warm it to check for the ammonium ion. The second test is to add ammonia and similarly check for a precipitate and state the color of precipitate, and afterwards, if a precipitate is formed, add ammonia in excess to check whether the precipitate dissolves or remains insoluble. Here are some examples of cations that would form a solid when added with sodium hydroxide. All zinc, lead and aluminium hydroxide are amphoteric in nature, which means they react with acid and alkali and hence soluble in excess alkali. And here are the equations of complex ions that are formed when the solid compounds have excess sodium hydroxide added. On the other hand, other hydroxides do not dissolve in excess sodium hydroxide since they are a base. And here is a list of cations and what precipitate would be formed when sodium hydroxide is added. Since ammonia is a weak alkali, it produces a low concentration of hydroxide ions, and thus calcium hydroxide will be produced when calcium ion is added and thus remains soluble. For calcium, when ammonia is added, there will be either no precipitate or a slight white precipitate, while in theory, there is no precipitate formed. However, in practical, traces of precipitate can be formed if aqueous ammonia is added in excess and the rest of the other precipitate formed is the same as sodium hydroxide. And here is the list of what precipitate would be formed when ammonia is added to cations. Zinc and copper are the two cations that form precipitates that dissolve in excess ammonia as it forms complexes as exhibited in the equations below. However, lead and aluminium cannot be distinguished by sodium hydroxide and ammonia, and therefore we need to make use of solubility of salts. The first way is to add potassium iodide where a bright yellow precipitate is formed for lead, while for aluminium it will form a colorless solution. The second way is to add hydrogen chloride acid, where similarly a white precipitate is formed for lead and a colorless solution is formed for aluminium. The last way is to add dilute sulfuric acid and the cations will produce the same results as the previous methods. In order to check for an ammonium ion, add sodium hydroxide, and if there is no precipitate formed, warm it and check for ammonia gas. Test for anions. In order to test for the presence of the nitrate ion, make use of Devarn's alloy in the zinc and aluminium, and the alloy will react with nitrate, and if the solution is warmed, ammonia is produced as seen in the equations below. The test for nitrate would produce hydrogen as well as seen in the equation below. In order to test for the presence of carbonate ion, we can add dilute acid and test for carbon dioxide as it will be produced in the equation below. To test for the presence of bicarbonate, similar to carbonate, we add dilute acid and test for carbon dioxide. To test for sulfate, we add dilute nitric acid in barium nitrate or chloride solution and it will form a white precipitate as seen below. To test for the presence of halides, we can add dilute nitric acid in lead or silver nitrate solutions and it will produce the precipitates as stated. To test for the presence of nitrite, we add Devarn's alloy again and warm the solution, and if ammonia is produced, nitrite is present. Test for metals. Some physical checks for metals is that it is silvery in appearance, it is malleable and ductile, and it is not soluble in water. The chemical tests for metals is to add an acid to it and test for hydrogen showing the presence of metals. Here are some images of the color of the flame when calcium, potassium, lithium, and sodium is burnt in it. And here is a list of the colors produced when other metals are burnt in a flame. And here is the color of metal oxides produced. When copper oxide is being heated in air, the color of the residue is black copper 2 oxide, while for lead tetroxide, yellow lead 2 oxide is formed. While for zinc carbonate, when it is heated in air, its residue goes from white to yellow and lastly back to white when the zinc oxide produced is cool. Tests for acids and alkali. Some physical tests include litmus paper and the taste of it. The chemical tests for acid is a metal reaction which produces hydrogen as previously mentioned, or a carbonate reaction which produces carbon dioxide, while for acid and alkali reaction, there will be temperature raises and the pH value will change. And lastly, to test for alkali, adding an ammonium salt would form ammonia. Tests for gases. The test for hydrogen is that it extinguishes a lighted splint with a pop sound, while for oxygen it relights a glowing splint. The test for carbon dioxide is that it forms a white precipitate in colorless lime water, and the white precipitate dissolves in excess carbon dioxide, and the equations of this chemical reaction is shown below. How do we distinguish between bicarbonate and carbonate? A way is to add calcium nitrate, and if carbonate is present, a white precipitate is formed as seen in the equation below. To test for sulfur dioxide, we add acidified potassium dichromate and it turns from orange to green as it reduces dichromate. And here is the list of tests of gases and how to identify them. Lastly, here are some terms to take note of and to not be confused about, with lime or quicklime being calcium oxide, limestone being calcium carbonate, slacked lime is solid calcium hydroxide, and lastly lime water is aqueous calcium hydroxide. That's all for today. Thank you for the effort to learn with me. Stay tuned for more interesting lessons. See you next time. Bye-bye.